Hello, today in this tutorial we are going to see how we can create real-time Spring AI text-to-speech application using ElevenLabs. So in our earlier tutorial, we created the text-to-speech application using Spring AI and ElevenLabs, but it had one limitation. So when it comes to the request processing, the end user has to wait for the entire processing to be completed before they could start listening to the generated audio file. So we can solve this problem with the help of streaming responses, wherein the response is being sent to the user on real-time basis in the form of audio chunks. So as soon as the audio chunks are generated, those are sent to the end user or client, and they could immediately start listening to the generated audio chunks, which will ultimately improve the user experience. So when it comes to the overall flow, this is how the flow will look like. So as an input, user will provide us the text content for which they want to generate the audio, and then along with this, user will also provide us certain parameters like which model they want to use to generate the audio and other related settings. Once this input is received, it will be forwarded to our Spring AI text to speech application, within which we will create the streaming prompt. This streaming prompt will be forwarded to the ElevenLabs text to speech model, and this text to speech model will interact with the ElevenLabs API, which will ultimately process our request and send the response in the form of streams. So when it comes to our application, this is how the overall project structure will look like, wherein the name of our application is Spring AI text to speech ElevenLabs streaming response, within which we have created one controller, text to speech controller. This controller will contain one endpoint. Then we have the DTO to accept the request from the user, which is text to speech request. Then we have the Spring Boot main file. Then we have the application.yml containing the configuration related to ElevenLabs. Then we have the pom.xml containing some project specific configuration. Apart from this, we have created one HTML file which we will go through while testing our application. Now let's jump into the IntelliJ. So here you will see the project structure is exactly similar to what we have seen just now. So let's start with the pom.xml. Here you will see the Java version which we are making use of is 21, and the Spring AI version is 1.1.0 snapshot. Now the support for ElevenLabs is available within Spring AI version 1.1.0, and as of recording this video, only the snapshot version is available, due to which we are making use of the snapshot version. And then inside the dependencies section, first we have added the Spring Boot starter web dependencies, which is useful for creating the REST APIs. Then we have added the Spring AI starter model ElevenLabs dependency, which is useful for interacting with the ElevenLabs. Then we have added the logbook dependencies, using which we will print the logs, which will showcase how our application is interacting with the ElevenLabs. Then we have added the Spring AI BOM dependency, which is useful for managing the Spring AI related dependencies. Since we are making use of the snapshot version, we have added the Spring snapshot repository related configuration here. Now coming to the application YML, at the very top you will see we have defined our application name. Then we have defined the AI configuration, within which we are passing the API key for ElevenLabs via environment variables. Then we have defined the configuration for text to speech, wherein we have set certain default options like model ID and the output format. So the default model ID is 11 multilingual v2, which supports various languages, and the default output format is set to MP3. And at the very bottom, we have just set the logging level for logbook dependency to trace, which will log the all interactions that our Spring AI application is making with the ElevenLabs APIs. Now coming to the main class, here you will see we have defined one additional bean, which is of type REST client customizer. Now since we want to log the request that our application is making to ElevenLabs, we have added the logbook client HTTP request interceptor, which will log all those interactions. So now coming to the text to speech controller, here you will see at the very top we have defined the base path for our controller, which is /API/text to speech. Then we have defined the ElevenLabs text to speech model, which will interact with the ElevenLabs, and we are initializing the same using constructor injection. Then we have created the stream endpoint, which is of type post. Now in order to accept the request from the user, we have created one Java record, which is text to speech request. If we go inside this Java record, you will see we have certain fields like text, which is nothing but the input for which user wants to generate the audio. Then we have certain parameters which are supported by ElevenLabs, like voice ID, which is nothing but the model that we have to use for the audio generation, the speed of the generated audio, and certain related parameters which will impact the generated audio. And if you see the response type, it is set to the response entity of streaming response body. So when it comes to Spring MVC, this is very important, which is allowing us to send the response to the user in real time basis. So instead of sending back the response in the form of byte array, via streaming response body allow us to write the data directly to response output stream asynchronously. So this is important. Once we have received the request from the user, first we will create the voice settings, for which we are creating the voice settings object. This is nothing but here we are specifying the parameters that we have received from the user inside the input request, like stability, similarity, boost, speed, and so on. So once voice settings are ready, we will create the text to speech options. First, we have specified the model, which is multilingual V2 model supporting various languages. Then we have specified the voice settings that we have created just here. Then we have specified the output format for the generated audio. Here we have set it to MP3, but there are various output formats that are supported, and the list can be seen here. So once the text to speech options are ready, we will create the text to speech prompt, within which we will specify the input text which user has given it to us. Then we have specified the text to speech options that we have created. And once text to speech prompt is ready, we will make use of ElevenLabs text to speech model, and then we will call the stream method, within which we will pass the text to speech prompt that we have created here. Now ElevenLabs will start processing a request and send us the response in the form of chunks. So due to which you will see the response type is set as flux of text to speech response. This is the class which is coming from ElevenLabs dependency that we have added. So if we go to this class, here you will see we have the list of speech results. Then we have the metadata. So once we have received the response from the ElevenLabs in the form of flux, which is nothing but the streaming response, now we have to send this response back to the user in real time basis. So here we have created one lambda function which is accepting the output stream as its parameter. Now this output stream is directly connected to the client HTTP response. Now inside the lambda function, here you will see the response that we have received. First we are converting it to the normal Java stream using toStream, and for each chunk of response, or we can say each chunk of audio, what we are doing is we are writing that chunk or writing that response inside the output stream, and then we are calling the flush method which will send the response back to the user in real time basis. So inside this you will see for the speech response or the audio chunk that we have received, we are extracting the audio content which is present inside the result. So here you will see we are calling the get result which will give us the speech, and from speech we will call the get output which will give us the byte array. Then we are calling the flush method which will send the response immediately back to the user. And once that is done, we are simply calling the OK, setting the content type header to /audio mpeg, and simply setting the response body, which is nothing but the streaming response body that we have created here. So this was regarding the how the response is being sent in real time basis. Now let's see our application in action. I'll restart our application. So once the application is started, we can test our application using two methods. First one is the index.html, which is nothing but the simple HTML file that we have created. And in order to access the same, we will have to go to the localhost 8080 index.html. So here you will see we have specified certain input, and then we have setting the parameters, which are nothing but the parameters that we have seen in our input request, like the voice ID, stability, speed, and so on. So now when we click on generate button, the request will go to our Spring AI application, which will forward it to the ElevenLabs, and we will get the response in real time basis. So as soon as I click on send, you will see the response is
Hello, this is
generated.
a real time text to speech streaming demonstration. You should start hearing this audio as it's being generated by the ElevenLabs API through Spring AI framework.
So here you will see we have logged the chunks that we have received from ElevenLabs, and each chunk is logged here, and also we have added certain logs just for our reference. And if you have to test our endpoint, streaming endpoint via curl, we have created one simple curl command. So which is nothing but it is calling a text to speech streaming endpoint, within which we are specifying the long text which we want to convert it to this audio. Then we have specified the parameters that are supported by our API. In order to play the response that we are receiving from ElevenLabs, we are making use of FF Play, which is nothing but the audio player without the GUI. And when we submit the request, you will see the response. As soon as we will receive the response, it will play immediately.
Hello and welcome. You are now listening to a live streaming demo of text to speech. This short passage is designed to test clarity, pacing, and natural intonation. Notice how the voice adapts to pauses.
So this was all regarding creating the real-time text-to-speech application using Spring AI and ElevenLabs. For this, we have also created one detailed article which you can go through, and the code that we have seen in this tutorial is uploaded on GitHub, so you can check out the code, add your ElevenLabs API key, and test the same. Yeah, so that's all from my end. I hope you found it useful. Thank you.